Continuing with section 3.2, I want to discuss next the end behavior of a polynomial. There's 4 cases to memorize. The end behavior describes the arrow direction of each type of polynomial. Let's begin with a polynomial that has a degree that is even. If the leading coefficient is greater than 0 or positive, the end behavior arrows are going to be what I like to call up, up. If the polynomial is even, but the leading coefficient is less than 0 or negative, it means the end behavior arrows are going to go down, down. Next, let's discuss odd degree. If the degree is odd, but the leading coefficient is greater than 0 or positive, that means the end behavior goes down, up. If the degree is odd, but the leading coefficient is less than 0 or negative, it means my end behavior arrows look like up, down. Let's take a look at a couple examples. In the following examples, let's determine the end behavior. Part A. I'm given the function f of x equals negative x cubed plus 3x squared minus 2. The degree of the polynomial, again, is the highest exponent, and in this case, it is 3. The LC I abbreviated, that represents the leading coefficient. The leading coefficient is the number in front of the term with the highest exponent, in this case x cubed. So in front of x cubed is negative, which really represents a negative 1. So our degree is an odd number, and our leading coefficient is less than 0. So that means, using a mini graph, our arrows are going to be what I like to call up, down. Let's take a look at one more example. Part B. I'm given the function f of x is equal to 2x squared times x minus 1 times x plus 3 cubed. This problem is a little harder because my polynomial is given to me in factored form. The only way to know the degree of a polynomial is to have it FOILed out. It must be in general form in order for me to pick up the highest exponent. So, foiling this one would be a little bit of a pain, right? I have x plus 3 cubed times another x minus 1. It's going to take a long time to FOIL. So instead of foiling, we use a little trick. We take each x term with its exponent and multiply it together. So I see I have x squared. Next I have x minus 1. There's no exponent there, so that means really it's exponent 1. So take the x with the 1. And then I have x plus 3 cubed. Again, just take the x with its exponent, which is 3. So I'm basically taking each x term with its highest degree, multiplying it together. So again, when my bases are multiplying, my exponents are actually adding. So in this case, I get x to the 6. So this means the degree of my polynomial is 6. Now my leading coefficient, as I can see, I have a 2 up front. All the other guys are just 1, so my leading coefficient is 2. So this time, my degree is an even number, and my leading coefficient is greater than 0, so it's positive. That means my mini graph arrows are going to go up and up.